Hi students, welcome to my lecture on mechanical unit operations. Today we are going to discuss about the practical aspects of finding the effectiveness of a screen, which is sometimes very confusing, and I hope with this video you will get able to get some clarity about how to find effectiveness of a particular screen, as we have different screens available, right? As we have discussed in the previous video, I have screen number 4, 6, 10, 20, 30, 60, 100 pan. These are the different mesh numbers of the screens available with us. And today I would like to find out what is the effectiveness of a screen number 30 or mesh number 30. That means our objective today is to find out effective and efficiency of mesh number 30, because it is important to find out the effectiveness of each and every screen, because based on that how efficiently it can separate the bigger size and smaller size particles can be defined. Today we have to do the three different analysis, as you people know that there are three things required to find out the effectiveness of the screen. One is oversize of feed, and oversize of fraction of feed oversize, and fraction of feed in the overflow, and fraction of oversize in the underflow. XF, XD and XB. XF denotes fraction of bigger size particles in the feed. Okay, XD denotes fraction of bigger size particles in the overflow. XB denotes the fraction of bigger size particles in the underflow. Once you get to know the three different fractions, you have to put it in the formula and find out the effectiveness or efficiency of a screen. Let us go ahead and do the experiment. Hi students, this is the Rotap sieve shaker, and it will give the rotating motion as well as tapping motion for the sieve shaking action. So now let us see how it moves. Madam, can you please start? Off the wheel. I hope you understand how the rotating action and tapping action will be there. Now we'll proceed for the finding the effectiveness of the screen. And hi students, these are the screens available with us, and we have 4, 6, no 10, 20, 30, 60, 60, 100 and pan. These are the sieves and pans, screens that are available. So among these screens, whichever may be the screen you can pick up, and we can find out the effectiveness of that particular screen. For example, if I pick up 30, screen number, mesh number 30. So how I can go on to perform the to find effectiveness of the screen. Let us take for example, now what we are going to do is, let us pick the 30 number screen and try to find out the effectiveness of it. To measure effectiveness of the screen number 30 or mesh number 30, I need to have three things in my hand. One is feed, and second is overflow. That means whatever the material that is on top of the screen 30, and the third one is underflow, whichever has been passed through mesh number 30 or screen number 30. These are the three things that are required. Dear students, this is the feed we have taken on the mesh number 30. Below the mesh number 30, we have kept the pan to collect the material. What we will do is, we are going to put this for the sieving action. What the things will happen? This is our total feed. After the screening action, watch out, the material that is left on this particular mesh will be overflow. Whatever has been come to the bottom, that is my underflow. And whatever I have started with, this is my feed. Now the mesh number and the pan are kept over the screening analysis equipment. What we do is, we take a 2 minutes to sieve this material, and later on we see how much amount of overflow and how much amount of the underflow. Okay. After doing the sieve shaking, this is the material that is left over the mesh number 30. This is the material that came through the mesh number 30. That means this is my overflow and this is my underflow. Now what we are going to do is, we are going to put separately analyze the overflow, we're gonna do separately analyze the underflow. Yes, students, this is our overflow material that is collected. What we do is we have to separately analyze the overflow. Now what we have to put all this material into the top screen again and do the screening action. What we do is now put all the material which is overflow to the screen number 30. Again you put every material on the top screen and perform screening action. What it does? Now again different particles will be collected as per the size given. Now we have kept overflow material into the screens. Now we will perform the screening action. After doing the screening action for the overflow, these are the different materials that is resided on the different mesh screens. This is for the 4 and this is 6, this is 10, this is 20, 30, 60, 100 and pan. These are the different materials, different sized particles on the different screens. We are supposed to measure the sizes on particles on each screens as well as what is the amount of these particles resided on every screen. Dear students, this is the overflow analysis. We have taken the readings of different weights of the materials that is stayed on the different mesh screens. Okay. Now, similarly, we have to do for the underflow as well. As we have collected the underflow from the mesh number 30, what we are supposed to do is keep all the put all the materials on the top screen and again you do the screening action. Similarly, we have to collect the different weights of particles collected on the different screens. After doing the screen analysis, we have separated the particles of different sizes into different screen numbers. And this is the pan. You can see there is a material that is left, and this is mesh number 100, this is mesh number 60, and this is mesh number 30. As you can see, very little amount of material is present on the mesh number 30. Ideally it should not happen because in the underflow there are some particles higher than the mesh number 30. That's what indicates. You can see very few amount of particles that is left as such on the material, and as you can see this is mesh number 20, no particles are left, and this is mesh number 10, this is 6 and this is 4, and we have to take the weight using the weighing balance on the material that is left on each and every screen, and once it is reported we have done the underflow analysis. Once this is done, we have to go for the total analysis, which is feed analysis. Okay, this is the feed material we have collected. This is a combination of overflow and underflow. Once you have done the analysis of overflow and underflow, we have mixed everything. What we are supposed to do is the feed analysis. Now overflow plus underflow is my feed. That means all the contents here are my feed contents. Now what I'm supposed to do is I have to analyze the feed analysis. Remember, we have to find three things. One is XF, XD and XB, and from this three analysis we get the different XF, XD and XB. Now what we're supposed to do is we keep all the material into the top pan. Again we do the screen analysis. Again we have to find out what are the different materials left on the different mesh screens. That is what the feed analysis. After doing the feed analysis, these are the materials that is left on each and every mesh screen. This is top screen 4, this is 6, this is 10, this is 20, this is 30, 60, 100, 100 and pan. You can see now the material. Now you have done the feed analysis. Now I can show you the calculations on how to find out the effectiveness or efficiency of the screen. Because from the feed analysis you get XF, From the overflow you get XD, from the underflow you get XB. These are the three things you're required to calculate the effectiveness or efficiency of a screen. Thank you. Hi students, these are the calculations that I have done to calculate effectiveness of mesh number 30, and this effectiveness is based on the oversize particles. Okay, whatever we have done, the mesh analysis for feed, this is the overflow analysis, this data comes from the overflow analysis, this data comes from the underflow analysis, and this data comes from the feed analysis. These are different mass of particles residing on each screen. So during the overflow, this is the mass, and during the underflow analysis, this is the mass, and during the feed, that means this is the mass. The sigma is summation of all the masses of overflow is 1577, summation of all the underflow is 347.5, and summation of all the feed is 1914 grams. So now our agenda is to calculate the mass fraction. You know, mass fraction during the overflow is nothing but 214 divided by 1577, which is 0.135. Similarly, 72 divided by 1577 is the 0.045. Like that, we can calculate the mass fraction of all the particles in the overflow. Similar way, we have to do the mass fraction of all the particles, in the underflow, and the mass fraction of all the particles in the feed. And during this underflow mass fractions, you have to divide 0 divided by 347.5, and 1.5 divided by 347.5 is nothing but 0.004, and 63.5 divided by 347.5 is equal to and 0.192, whatever. Like that, during the feed, you have to divide this feed grams divided by 1914. Like that, you are going to get the fractions of overflow, underflow, as well as the feed. Now, what is XF, XD, and XB in our calculations? Imagine, as we are finding out the effectiveness for the overall party and overall oversize, the summation of all the particles over the screen number 30 is my XD. The summation of all my underflow up to the screen number 30 is XB, and summation of all the fractions till the screen number 30 will be my XF, because these are the particles, these are the all the fractions which are higher than the mesh number 30 diameter. So that is why we have to consider, because we have done the analysis for the mesh number 30, these are the total that we have to summate the all the fractions over the screen number 30. That is why summation of all over this 30 from the overflow analysis will be XD, and summation of all the underflow is for the XB, and summation of all the fractions over the feed, and this particular is XF. Once you know the XF is 0.326, XD is 0.398, and XB is equal to 0.004, and put up all this in effectiveness formula, because effectiveness of screen number 30 is nothing but XD into 1 minus XB, XF minus XB, XD minus XF, XF, 1 minus XF, and XD minus XB whole square. Okay, once you put all the fractions XF, XD, and XB, you get the effectiveness of the screen number 30 is 0.264. In other words, the percentage is nothing but 0.264 into 100, which is 26.4% effective or efficient. That means this screen is only 26.4% effective in separating the particles. So this is how we have to calculate the effectiveness of different screens. Like that way, I have done it for the mesh number 30. And similarly, we can calculate the effectiveness for the different mesh that is available in the laboratory. And thank you very much.